welcome back. So here's another problem regarding the area. So let's find the area in the third quadrant bounded by the given x is equal to y squared plus 2y. So as you can see here, this is an example of a parabola. Once again, a parabola. Okay. So we need to determine the area bounded by this curve. So let's have our x and y axis here. Then we need the quadrant 3, this quadrant. So bounded by this line, by the negative x-axis and negative y-axis. Okay, so this is our quadrant 1, 2, and this is 3. This is our quadrant 4, right? Okay, so we only need this, plus we need to sketch this parabola x is equal to y squared plus 2y. Okay, so let us review the vertex form of our parabola. Say vertex form, we have review, so we also need to review our aside from algebra and trigo, we also need our analytic geometry here. So we have x is equal to some constant a multiplied by the variable y minus constant k that is being squared plus constant h. Then we can from this form our vertex is h, this h here, and then k, hk. This is our x coordinate and y coordinate vertex. Okay, so let's transform our given formula on this form. So we have x, then y squared plus 2y, y squared plus 2y. Okay, so as you can see here, we have some variable y that is being squared. So let us do the completing up square. So let's try y plus 1 that is being squared. So if we have this is also equal to y squared plus 2y. So we've got already this form, but we have the plus 1, right? Because 1 squared is 1. If this is our form, then in order for us to make our equation equal, we need to add 1 also here. Okay, now this form here is also equal to our original equation, right? So by doing that, let's rewrite furthermore our x in terms of this form. So we have x. So we have x is equal to y, since we have negative here, negative times, so negative times negative, we have positive 1, y plus 1 squared, then minus this one. If we will move this positive 1 or plus 1 on the other side, then we will have a minus 1. But since we need to determine this in this form, let's plus a minus 1 here, so that we can easily see which is k and which is h. By having this form, as you can see, we have x, this one, is equal to our a, wherein our a here is 1. And then y, we have y, minus our k is negative 1, plus h is also negative 1. So this is our h. Okay, so by having this form, we can now determine our vertex, which is hk. So our h is negative 1, as well as our k is also negative 1. This is our v. So by doing that, let's plot it on our x and y axis. Say this is our negative 1, and this is also our negative 1. Let me extend my y-axis. Yan. So negative 1, negative 1, negative 1, negative 1. This is our vertex. Then we need to determine the point that intersects our x-axis and y-axis and our parabola. Okay, so let me erase this first. Okay, so as you can see here, if we will let our since we need the intersection in this x-axis, if we will let our y equal to 0, then what will be the value of our x? If y is equal to 0, then x is equal to 0 squared plus 2 multiplied by 0. All in all, x is equal to 0. So our coordinate is just 0, 0. 0, 0 is this point, right? And that is 0, 0. Okay. How about on our y-axis? Okay. So let our y, the x-axis, let us our x is equal to 0, then let's find the value of our y. Okay, as you can see here, if our x is equal to 0, one answer is that our y is equal to 0. So let's find out here by letting our x is equal to 0 the value of y. So let's find the value of y having this equation again. So we have x is equal to y squared plus 2y. And if we let this x is equal to 0, then we have y squared plus 2y. And by doing the algebra, we can factor out y. So we have y plus 2 equal to 0. And then we can now compute the value of y. Y is equal to 0. And for this one, y plus 2 is equal to 0. Then y is equal to negative 2. Okay. As you can see here, as what we have expected, if the x is 0, our y is 0. So we have x is 0, our y is 0. And the other y is, if our x is 0, other y is negative 2. So we have 0, negative 2. We have x is 0, and then y is negative 2. See, this is our point. Since this is negative 1, see, this is our negative 2 right here. Negative 2. Once again, we have 0, negative 2. So we have 0, negative 2. And that is this point. Then we can now graph our parabola. I hope I gave justice on my graphing here. I'm having a hard time using this Wacom. But anyway, say that let's say that my graphing is just somewhat correct. Forgive me on my drawing. So we have here areas bounded by this parabola or by this curve having equation of x is equal to y squared plus 2y from the intersection point of x and y axis at quadrant 3. So all we need to do is to determine the area bounded by this, all of this area. Yan. Yan. Okay, need to find this area. Okay. So after graphing and sketching what we need, then we need to select a strip to represent, say let's have a strip here. Say this is our element that is equal to, as you can see here, this is equal to this length is equal to negative x, right? This is negative x, and this is dy, change of y, dy, right? So using our formula, we have the dA is equal to the integral of the negative x dy. Then we have a is equal to, from our point, lower limit is, since this is y, so we have negative 2 up to 0. Negative 2 to 0, then we have negative, and the value of our x is y squared plus 2y dy. Then taking its derivative, we have a negative y cubed all over 3 minus 2y squared all over 2, from our limit is from negative 2 to 0. From negative 2 to 0. Okay, so evaluating this, we have, since we have 0, this, if y is 0, then this whole term here, 0 over 3 minus 0 over 3, we have 0 minus the negative 2 cube all over 3 minus 2 times negative 2 y squared all over 2, or let's cancel this out pala so that we can simplify our equation. So we have y squared, negative 2 squared. So simply we have negative 2, negative 2, negative 2. We have negative 8, negative, we have negative 8 all over 3, positive 8 all over 3. 8, 2 times 2, 4 times 2, negative plus positive, yeah, positive 8 all over 3. Then 4 minus 4. So we have a negative 8 over 3 plus 4, or this is equal to this is equal to 4 all over 3, positive 4 all over 3, right? Square units. This is now the value of our area. Okay, so let us review. Need to find the area in the third quadrant. So our boundary is by this negative x-axis and negative y-axis here, and by the parabola given by this equation, x is equal to y squared plus 2y. So we need to graph the parabola. So instead of taking many points like what we did before, so instead of doing that, we've tried to locate its vertex and then the intersection points along x and y axis. But it so happened that the intersection point along x is at 0, 0, and along y is, we have 0, negative 2. Okay, that is the coordinates. And then we've tried to plot this parabola. Then we've come up with this parabola that looks like this. And then we take some strip to represent, or to represent our rectangle, which is the side here is equal to negative x, wherein we can also get the value of this negative x using the equation here. That's why we have here y squared plus 2y with negative sign here, and then our dy, so that we can have the area of this strip. And then we've tried to sum all the strips from negative 2 to 0, to summarize, or to take the totality of the area of the strips from this limit from negative 2 up to 0. And then after that, we perform the integration and come up with our answer that is equal to 4 over 3 square units. So thank you. That's all for this example, and see you on our next video.